to this year's Generative AI and Justice Conference. My name is Karim Beniklef, and I'm the director of the Cyberjustice Lab and a professor here at the Faculty of Law, Université de Montréal. So it's great to see you coming from a different sector to discuss the future of generative AI and the law. First and foremost, I would like to express my gratitude to our distinguished panelists who have given their time and expertise to make this meeting possible. We look forward to the rich discussion that will unfold today. Thank you as well to all the attendees. We are fortunate today to have Professor Pamela Samuelson from Berkeley, who will deliver our keynote address on risk and opportunities posed by open versus closed foundation models, which is clearly a timely and important topic and a point of contention for big tech companies. Following this, we'll have 4 panels lined up, and I believe that by the end of the day, we'll have a deeper understanding of the various aspects of the intersection of generative AI and law. The theme of this year's conference, Practical Application of Generative AI Across Industries, Real-World Insight and Future Direction for Access to Law and Justice, reflects both the opportunities and the challenges AI presents to us today. Our goal is both simple and deep, to foster interdisciplinary collaboration that drives real-world solutions. We are not looking ahead to the future of AI, but also reflecting on the substantial strides already made. By bringing together experts from different fields with different perspectives, we aim to create a space for meaningful dialogue that bridges the gap between technological innovation and practical application in the delivery of justice. Here at the Cyberjustice Lab, we have long been at the forefront of exploring how emerging technologies can enhance access to law and justice. One of our landmark projects is the ACT project, ACT standing for Autonomy Through Cyberjustice Technologies, a large-scale 7-year initiative involving over 50 researchers and 42 partners from the public and private sector, academia, and NGOs. At the ACT project, we study the technological tools that can help in conflict prevention and resolution, making sure that technology is deployed responsibly and ethically in the legal sphere. This project has been significant in preparing us for the important change that generative AI is now causing in the legal field. Another important initiative is the Justice Bot, and I have one of the creators of the Justice Bot here today, Anes. I'm very happy. Another important initiative is the Justice Bot, an AI application developed in collaboration with the Housing Tribunal of Quebec. Justice Bot provides legal information to the public by asking a series of questions. Justice Bot was created with a carefully chosen and designed combination of symbolism and connectionism, using decision trees to ensure information accuracy and language models to guide users through complex questions. We also experiment with using LLM to assist human experts in creating decision trees, but this will always be validated by experts before presenting the tools to users. Since its launch in July 2021, JusticeBot has been used by more than 40,000 people, providing a glimpse of how AI can facilitate and expand access to legal information. The reason we are gathered here today is to share, understand, and promote the responsible integration of generative AI across various fields. In this integration, not only are the underlying capabilities of the model important, but how these models are applied is also, of course, crucial. Looking back to the time before the release of ChatGPT, models like GPT-3 did not generate significant attention outside of academic communities. It was the intuitive interface of ChatGPT that simplified interaction with the model, unlocking its potential for broader application. Now, almost 2 years later, with more advanced models emerging, we observe that the underlying capabilities have not advanced as dramatically as initially claimed by the big tech. And issues like hallucination persist, which is, of course, a serious impediment, especially for legal matters. The state-of-the-art models still struggle to handle simple problems. Most post-training methods are being employed to enhance model performance, and this is where we, as a community, can make significant contribution. In the justice sector, the biggest challenge we face is not deploying legal AI chatbot, but finding ways to apply AI accurately, transparently, and fairly. Giving the lay people user legal information that is only 90% accurate is not the goal. I think there will be a discussion about this in today's session as well. New techniques such as retrieval augmented generation, RAG, as well as multi-agent system can help AI improve the reliability of results before they are output, but this, of course, still require further work and evaluation. Our goal is to create tools that are trustworthy and comply with the principle of justice. In addition, we face significant barriers to regulation, bias, and the practical integration of AI into existing legal system. While AI holds great promise, we must remain vigilant, very cautious, to make sure that its application do not aggravate existing inequalities or create, as a matter of fact, new ones. It is through our collective efforts that we can unlock the potential of AI, improving access to justice and to law, while upholding the ethical standards that support our justice system. So, it's my great pleasure to introduce Professor Pamela Samuelson. Pamela Samuelson is the Richard M. Chairman 74 Distinguished Professor of Law and Information at the University of California at Berkeley and the Director of the Berkeley Center for Law and Technology. She teaches courses on intellectual property, cyber law, and information privacy. She has written and spoken extensively about the challenges that new information technology pose for traditional legal regime, especially for intellectual property law. I remember that we had the pleasure of receiving her in 94, 95 here at the at the Public Law Research Center. She's the co-founder and chair of the board of directors for Authors Alliance, a nonprofit whose mission is to facilitate authorship in the public interest. She's also a member of the board of directors of the Electronic Frontier Foundation, as well as a fellow for the Center for Democracy and Technology and a member of the advisory board for public knowledge and the Electronic Privacy Information Center. Thank you again, Professor Samuelson, for accepting our invitation. The floor is yours.
Okay, so hi, I'm Pam Samuelson, and thank you for the invitation to be here, and I hope that my remarks will be of use to you. Obviously, one of the first things that you might be thinking is the same thing as I'm thinking, which is, why am I here? So here's an overview of the talk. But I think the first question that's worth addressing is, why am I here? My initial reaction to the invitation was, why me? I'm not a cybersecurity person, and I'm not an expert in justice either, although we all aim to promote justice. But I thought about it a little bit more, and I said, you know, much of my work focuses on how law and policy adapts to disruptive technologies. And so I thought, well, maybe I can find a way to bridge what I know. I'm mainly a copyright person. I'm mainly an intellectual property person. So is there a bridge? And so I said yes, and partly because I said, well, I think I can put together a talk that might be of interest, but also I'm here to learn from you because I'm not a cybersecurity person, you are. Cybersecurity 20 years ago was something that a few nerds cared about, but nobody else did. And so it's been amazing to see that it has become its own field of research and not only of concern to companies with a lot of data, but also generally to us all, because our data is stored in so many places. And so we all care about cybersecurity now, even though we never thought we would ever have to think about that. Anyway, I thought that actually what I could do is talk a little bit about the debate about open versus closed, a debate that started quite a long time ago in the software area, and then say, what are the things that we were concerned about back in the 1980s and 1990s about software? how do those transfer over to AI systems? And so I thought, well, I can probably do that. And, I recognize that openness of AI systems is now widely perceived to be a bigger risk than software, more open software, more generally. So I thought, well, let me start by telling a little bit of history. So the history is, again, coming at this from an intellectual property scholar's standpoint, is like back in the 1980s and early 1990s, intellectual property lawyers just couldn't imagine that open source was something that was viable. Okay, maybe some academics out there and maybe Richard Stallman, but nobody who's serious would ever do open source software because you wouldn't have the exclusivity that the intellectual property lawyers thought was the whole point of having intellectual property rights, was so that you could control exploitations and therefore make lots of money. And IBM was for a very long time the most rigorous proponent of closed source, closed source, closed source. And then when they weren't as dominant as they had been, and when Microsoft basically became the big monopoly instead of IBM decided, hey, maybe there's something to this open source software. And so intellectual property lawyers had to kind of change their understanding. Once IBM goes over to open source, hey, maybe there's something to this after all, and maybe there are other ways of essentially monetizing software than just licensing individual copies to individual people and firms. So one of the things that is obvious to all people who are technologists is that the open source collaboration means that you don't have to bear all the cost yourself. You have you build a community around your open source project, and that community then contributes and then adapts the software in ways that actually make it more functional, and bugs become shallow, etc. And so it kind of was a transformation of my field to think about open and closed in a different kind of way. Now, one of the things that Larry Lessig, who is probably known to most of you, a legal scholar who basically was once the most avid endorser of open source software. And one of the big advantages that Larry saw in open source was the governments can't control it, right? So once it's loose to the world, even if the US government or some other government wants to stop it, maybe it could stop it locally, but it can't basically stop it throughout the world, and so that's pretty interesting. Now, Larry Lessig is actually opposed to open AI systems, and that's kind of interesting too, because it's a pretty big turn. And what's going on? It's because he thinks that the risk of malicious actors adapting these systems and essentially undermining societal values is so great that we need to restrict it. Now, one of the things that obviously you are probably as aware of or more than me, which is open doesn't always mean exactly the same thing. And so I thought it would be worth spending a minute talking about different ways we can think about what it means to be open. So, different aspects of software have different kind of openness, right? So openness may relate to the code, it may relate to documentation, it may relate to APIs, it may relate to training data, it may relate to weights. And so each of those has its own kind of thing, and some parts of software may be closed as to this but open as to that, and so we have to have a nuanced understanding about what openness means. In addition, there are ways in which something can be partly closed and partly open. So structured access, for example, some parts of it may be available to individuals for certain purposes. So weights are made available, for example, to researchers, but not to everybody else. There's also the concept of kind of stage release, right? Starts off more closed, and then as the system becomes understood to be safer, then what you do is you open it up a little bit more as things get more trust in safety. And of course, open source, when it comes to different components of software, also doesn't mean that it's not restricted at all, because open source licenses, which of course depend on copyright existing in the code to impose that license, because you can't license something if there's no intellectual property rights, basically, to do it, although God knows lots of people are doing that anyway. But the point is that the licenses also regulate how open something is. And of course, even if you have a closed source system, there may be other types of documentation, such as model cards, data sheets, and the like. And of course, the base model may be open, but customized versions may be closed. So it's a really nuanced concept, I think, that we have to pay attention to. Now, I'm not going to go through the many benefits of AI systems that we all can imagine. Okay, they're all over the place, and that's part of what makes it kind of head-spinning to kind of think about. But let's spend a minute on the benefits of openness. So open AI systems can be made very widely available to a wide array of researchers. That diversifies and expands the AI system reach, and it enables a lot of follow-on innovation, which actually we all would care about a great deal, including by firms and individual researchers who could not afford to develop the AI base models themselves. Decentralizes the market, creates opportunities for entry, and to the extent that I can take a model and put it inside my firewall and then feed it privacy data that I wouldn't want the rest of the world to get access to. It can also be used to protect privacy. It's obviously easier to audit, more transparent, and the developers can install guardrails to deter accidental or malicious tampering. And so that's all of the benefits. Now, are there risks? Yeah. That's what a lot of people in policy-making positions are concerned about these days, because once an open model, particularly as to weights, are deployed, the developers lose control over them, right? They're out there in the world, and you don't know where they're going, and you don't know who's using them, and so you can't monitor for abuses the way you could if it was a closed source system. And even if the base model is trustworthy, customizations may not be. The sophisticated threat actors may remove the guardrails. They can fine-tune the models and weights and enable malicious uses of it. And if you kind of like discover as a developer of the base model that, oops, we have a security problem here, you may be able to patch it, and you may be able to patch it as to the people that you know about, but there are going to be lots of people out there that won't receive the patches, and so that's a concern. And from the standpoint, again, of many people, you can't as easily regulate it as you can if it's a closed system. So again, I'm not going to go into the range of plausible harms, but you know what they are, probably even more than me, but these are at least some of the ones that I've been able to identify from the literature out there. Now, closed source has some real benefits, and it's important to kind of recognize that too. It's less likely, it's not impossible, but it's less likely to be customized for malicious uses. You got one developer to hold responsible if the harms begin to show up out there in the world. you know who your customers are, you can monitor the usages, and you can take action against somebody who begins to abuse the system. And if a patch is needed, you can send it out to everybody at the same time. And so you make sure that actually the patches really happen. And the developer has incentives really to make the system safe because their reputation depends on it, and also their ability to commercialize it, right? If you don't have trust in it, then you won't use it. And so there are lots of things about it that actually are benefits. Now, are there downsides of closed? Yeah. The idea that they can't be hacked is ridiculous, okay? So, you know, we all want to think that they're completely secure, but they're not. So it's important to recognize that they can be hacked too. They're not as transparent, and frankly, the developers don't always want to let you know what's going on. Maybe they're willing to do inside audits, but allowing outsiders to come in and audit is actually something that they're kind of less enthusiastic about. But that partly means that their systems may not, in fact, be as secure as with open models, where people can basically say, hey, fix this, okay? And there are concerns about competition, right? If countries ban open systems, then the dominant firms that basically have launched a lot of these things are going to end up being entrenched, and then it's more difficult for competitors to erode that dominance. And there's arbitrage problem here, because let's say Canada or the United States decided to ban open models. Well, that doesn't stop the rest of the world from doing it, and so that may be a disadvantage to the nation that decides to do the ban that then other nations are able to take advantage of. And again, development in respect of AI can happen any place. It's not just, I mean, you need compute, okay, got that, but compute can move too. And so it's important to sort of recognize that, you know, it's not entirely an easy situation. So again, much of the concern about open versus closed has to do with sophisticated threat actors. And you can name them probably much better than me, but of particular concern is the military intelligence, national security services from countries of concern. You can fill in your own, but China's mine. And then criminal syndicates, terrorist organizations, lots of threat actors out there. Is there a need for regulation because of these risks? Well, some people think so. So the California legislature recently passed a bill known as SB 1047. It would, among other things, require the installation of kill switches so that the system could be shut down. And then also had a set of requirements about you can't release your stuff until these safety measures are shown to be good. And they were going to set up a whole new agency in California to sort of fill in the details, because the legislature couldn't really figure out all the things that needed to be. And now, this to me is like red flag, red flag, red flag. Okay, you don't know what you're doing if you do this. If you kind of like can't put it in the legislation, you create an agency, and then you fine people really badly, right? If they don't comply with something, they don't even know what the standard is. Okay, well, don't get me started. There was a lot of opposition to 1047 among industry groups, leading AI researchers, several members of Congress, particularly Zoe Lofgren, who is a representative in the South Bay in California. And I think the first part of it, I think, is something that, again, you can probably relate to, is that if you don't have standards, benchmarks, evaluation protocols already developed to kind of say what's safe and what's trustworthy, passing a legislation that basically says you got to do this is like, okay, what does that actually mean? I think the second thing that Zoe in particular focused on was that the kill switch thing is really kind of worrying about an existential threat, whereas we should really sort of say, what are the threats now, right? And we can basically adapt over time. But one of the big concerns, especially among the leading AI researchers, was that as they interpreted the 1047, open models and open weights actually would be at risk of not compliance and therefore could be shut down. And again, a lot of researchers at Berkeley, Stanford, and many other universities are relying on the openness of certain models to then customize them and to then build on them, build applications to interact with them, and so forth. So it's really important to sort of realize that the openness or closeness basically affects a large community of people who would want to be engaged in AI development. And so, the concern about effects on U.S. competitiveness is also a real important thing. So Governor Gavin Newsom decided at the very last minute, he had till the end of September, and he waited till the 29th, to veto this particular bill, questioning whether the legislation should be based on the amount of compute. That's actually the focal point of 1047 was on the size of the compute. And rather than on what does the model doing, is basically about how much compute there is. And one of the things Newsom kind of notes in his letter explaining his decision is, number one, let's evaluate actual risks of these applications in high-risk deployment spaces rather than trying to base it on compute. And also, 1047 would give the public a kind of false sense of security, because the idea that smaller models aren't dangerous is really not accurate either. And so, again, he wasn't opposed to the idea of having some regulation, but just really thought it was premature to do and would undermine innovation and open science, which depends on some systems having openness. So, yeah, I agree that there should be guardrails, there should be safety protocols, and hold irresponsible developers to account when they have caused harm. But the idea that you kind of just create this whole regulatory scheme when you don't know what you're doing is not a good idea. So the Biden administration also was concerned about the open versus closed system. And you may have heard that the Biden administration issued an executive order about AI policy, and it's a pretty lengthy document. Much of it basically articulates the administration's goals for AI policy and AI regulation, but it also directed many agencies to come up with reports and standard protocols and advance the science of safety testing in the context of AI. So NIST has responsibility for advancing science of safety in AI systems. The Energy Secretary was tasked with developing protocols for safety testing and evaluation, and NTIA, the National Telecommunications and Information Administration, was tasked with taking up the report, writing a report. So they issued a set of questions. This is known as a kind of notice of inquiry. You pose a bunch of questions, you give people who are interested in it an opportunity to submit reports and answers to the questions that were posed. And it recognized that the main argument against open systems is however carefully they may have initially been designed and developed, once deployed, users who tinker with them can make changes which will undermine cybersecurity, public safety, privacy, and other kinds of societal goals. Okay, so we recognize the risk, and the proprietary systems can be more easily controlled, so they're less risky, but they recognize, NTI recognizes they can be hacked too. And NTI ultimately concluded that there is insufficient evidence at the moment, based on the submissions that were made to them and based on their own independent investigation, that open systems are too vulnerable to harmful uses to support a ban on them. Okay, so that's actually where we come out, but NTI said, that's not to say this is the end of the conversation, right? This, in fact, is a point in a longer term process, so we will continue to monitor developments, and if things become more scary, then we'll start initiating some sort of policy adjustment as needed. Now, one of the things that I found interesting when first asked to do this particular talk was that you guys think that cybersecurity has something to do with justice. And I'd say not everybody does. So I said to myself, well, what does this have to do with justice? And so I thought of two things, right? So open foundation models may be more likely to facilitate the kind of socially desirable goals that I had in one of my earlier slides, right? Because proprietary system developers have to maximize profits, and so the open models may be used by nonprofit researchers, such as people at UC Berkeley, to kind of use the open models and systems to essentially develop those applications for beneficial uses. I just heard a presentation a couple of weeks ago that someone in the environmental field did, which is they're using data science and AI systems to basically assess reforestation possibilities as a means of controlling CO2 in the air. And they're able to map things so much more efficiently, and so if deployed and reforested, that could increase the ability to capture CO2 and make our air better and also reduce climate change. Okay, so that was one really nice example that I saw. So that's an important thing. But the other thing is that victims of malicious uses of these foundation models are likely to be people who are disadvantaged. So justice may be served in part by allowing openness, but it also may be disserved. And one of the examples that I found in the literature was GPT-4chan, which is a hate speech chatbot. You want to do hate speech? You can go to this place and get that, but we don't like that, right? Those are things that actually hurt people. Okay, my concluding thoughts. You are cybersecurity researchers. You have a considerable experience assessing risks and analyzing how they may be mitigated. The open versus closed AI system debate is only the most recent manifestation of this particular puzzle that you've been working on for a very long time. You will have much more informed judgments than me about how to assess those risks. But from where I sit, Governor Newsom's decision and the NTIA's conclusion seem sound, but as NTIA noted, the prudent course is to keep monitoring developments and be prepared to act against abuses. Thank you.